Where am I? Here I am. Okay. All right, we've still got a couple minutes before we begin. How's everyone doing? Excellent. So today, this is a tricky chapter, but it is shorter than oh, hello. Sorry, my large cat is leaving. Um, Yes, it's a little bit shorter than the previous one. Some of the content, especially towards the beginning, is a little bit tricky, um, but I don't think this chapter is quite as difficult as I initially made it out to be. So today, hopefully, once we get through the beginning, should be rather painless. Before we start, I do want to mention that your quiz number, well, what number is it now? Quiz number 2 results will be available this evening. They're all graded. I just want to look over a few things before I release everything, but those will be released to you shortly. Um, is it 3? I thought we were on quiz 3. Quiz 3 is happening now. Um, yeah, we're on quiz 3. So quiz 3 is open. You can complete that anytime before Friday at 11:59. And then later today, the results of quiz 2 will be made available to all of you. And then Karanvir and I are going to get started on getting those essay proposals marked and returned to you with lots of good feedback so that you can go ahead and get started on your final papers. So now that it's 2:35 and more people are here, we can officially get going. So we're going to talk about mind as a causal system, or causal-theoretical functionalism. Last time we talked about Turing machine functionalism, or sometimes just machine functionalism, where we liken the mind to a type of computer, a probabilistic Turing machine. And remember, Turing machines are not actual machines that we build, right? They're imaginary, conceptual or theoretical machines that we can use following Turing to understand computation. In fact, this was how Turing formalized the notion of computation with the notion of a Turing machine and a mechanical step-by-step procedure that we call the algorithm. Now, on machine functionalism, recall what is important are mental states and their functional relations to one another and to inputs and outputs, right? All the functional relations of the system, all the states that the machine can be in, um, are kind of what mediate inputs and outputs, right? We saw this last time when we looked at our example adding machine. We can have a Turing machine defined to add, like, I forget what the number was, 5 plus 3, right? So it takes 5 and 3. It takes it takes the input 5 plus 3 in unary code and outputs 8 in unary code. And what matters are the inputs and outputs and the information processing steps in between. That's what matters for a functionalist, not how it's all physically realized. Similarly, if we're analogizing with a human being, in our case, we have some input like tissue damage, which causes C fiber stimulation, which leads to an output like pain behavior, winces and groans, and so forth. That's how it is for us, but it might be otherwise in other creatures, right? And that gets us to this idea of multiple realizability or multiple realization, which is the idea that we can implement or realize different kinds of computations with different physical stuff, right? So causal theoretical functionalism is a little bit different from machine functionalism. Machine functionalism likens the mind to a Turing machine. Causal theoretical functionalism focuses on the causal relations that sort of underwrite our input-output relations. So they're not quite looking at minds as Turing machines specifically, what they're focused on are the causal relations between the inputs and all the intermediate states, and the outputs of the system. As Kim says on page 169, causal theoretical functionalism conceives of this input-output relationship as a causal relation, one that is mediated by mental states. Different mental states are different because they are implicated in different input-output causal relationships. Pain differs from itch in that each has its own distinctive causal role. Pains typically are caused by tissue damage and cause winces, groans, and escape behavior. In contrast, itches typically are caused by skin irritation and cause scratching. And it's important to note here that inputs and outputs can also include other mental states, not just perceptions when we're talking inputs, and behaviors when we're talking outputs. So that's an important thing to understand. Like, my inputs are not just tissue damage or skin irritation, right? They could also be, for example, other beliefs and desires in the system that could serve as an input to a certain computation, right? So that's important to keep in mind. Could I clarify multiple realizability? Well, multiple realizability is a key concept in functionalism. The idea is that you can implement different systems, or the same system rather, using different physical stuff. So the running example in this book is pain, right? Pain is C fiber stimulation, as the identity theorists would have it. They want to say that pain just is C fiber stimulation. A functionalist says, well, hang on. There could be non-human animals that experience pain but don't have C fibers. Pain must be implemented in a different way. Maybe they have, just for imagination's sake, X fibers instead of C fibers. So that's another way to realize pain. And of course, the toy example I always go with is that of a calculator, right? I can have, of course, I'll get my trusty old calculator, which I swear I don't even use for calculating anymore. I only use it for examples of multiple realizability. But you can have a calculator made out of hardware, right? Circuit boards and so forth, like this graphing calculator. Or you could have a virtual calculator like the one on your computer or your smartphone. Or you could have a different kind of hardware altogether, like an abacus. You're sliding beads all over the place, and the different configurations of the beads represent different numbers, and you can perform calculations with an abacus rather than this kind of calculator. Yeah, that's exactly right, Aldwin. Multiple realizability is how a function can be realized. I would say realized, not work, but realized, brought into being in different ways with different materials, right? That's multiple realizability. Kim asks if there is a danger of circularity when it comes to thinking about defining the functional roles of mental states with respect to other mental states. This is what he says on page 170. To explain what a given mental state is, this is on causal theoretical functionalism, we need to refer to other mental states. And explaining these can only be expected to require reference to further mental states and so on, a process that can go on in an unending regress or loop back in a circle. So, think about it this way. If I'm trying to explain some kind of behavior, for example, I might appeal to beliefs and desires. If we're looking at the mind as a functional system and we're doing it through our causal theoretical lens, where we're focused on the causal role of mental states, then think, for example, of someone, just a toy example, like, taking their umbrella with them when they leave the apartment, right? We've used this example before. So I see my roommate take their umbrella with them. when they leave. So how do I explain that? Well, I could come up with a little theory that explains what caused my roommate to leave with their umbrella. Perhaps they believe that it is going to rain later and they desire to keep dry. Okay, that seems pretty straightforward. But how do I understand the role that those beliefs and desires play within the system? Okay, I've got to include all kinds of beliefs about the properties of rain and about how umbrellas work and how are those grounded in further beliefs, on and on and on, beliefs all the way down, different mental states all the way down, such that we have a worry of an infinite regress. And remember, infinite regresses are something that we want to avoid when we're theorizing like this, right? But Kim also adds that circularity threatens to arise at a more general level as well in the functionalist conception of mentality itself. To be a mental state is to be an internal state serving as a causal intermediary between sensory inputs and mental states as causes on the one hand, and behaviors and other mental states as effects on the other. Viewed as a definition of what it is to be a mental state, this is obviously circular, right? How do we escape this? Well, machine functionalism uses a Turing machine to escape this worry, right? How so? Can you see how the Turing machine helps us escape this worry about circularity? Maybe we can get a little discussion going in the chat, or people can raise their hands if they'd like to contribute. And don't be afraid to go take a peek at the textbook. You know. Anyone want it? Last chance. Anyone want to take a guess? Okay. So remember that a Turing machine, granted Putnam thought that human beings were probabilistic Turing machines, but Turing machines, as conceived by Turing, are completely determined by their prior states and the rules of the program, right? They're completely determined by their machine table. So we don't have to worry about this regress, right? Because everything is kind of completely defined. Everything about the machine, all the states that it can be in, is defined by its program, its machine table. Now, we are probably not determined Turing machines. At least I hope we're not. We are arguably probabilistic Turing machines, which means that we're not completely determined like a classic Turing machine, where if it's in such and such a state and the machine table says, if in this state, then do this. Otherwise, if you're in this state, then do this, and so on and so forth. We don't have this exhaustive deterministic list of instructions, but there's a probability that given A, I will do B, but sometimes I might do C or D, right? So I have if I'm a Turing machine, if you're a Turing machine, we have a sort of probabilistic machine table, with which you could define the program that is you, if you want, right? And everything in that machine table is all kind of interdefined. And we don't have to worry about circularity or an infinite regress. Well, that's a good question, Taylor. Taylor's asking, are we not determined because we have free will? I mean, some people would say absolutely we do have free will, and some people would say, nah, we don't. We actually are like a sort of classic Turing machine. We are machines ourselves, and we are therefore determined. Let's have a little digression on this, actually, because it's an important thing to keep in mind when we're talking about mind. And we will talk about it when we discuss mental causation, which is, I believe, the next chapter that we're going to look at. But this is maybe a bit of a cartoonish characterization, but, there are like three big, broad camps here. you have your libertarians who say we are free. We're metaphysically free. We're not the kinds of beings that are determined, right? Descartes would endorse this with his substance dualism. I think probably all of the Abrahamic religions certainly would endorse libertarian free will, because we have souls, and souls are endowed with free will by God, right? So that's the idea there. We're metaphysically free. We're not the kind of beings that are determined in the same way that physical processes are. That's libertarian free will. Then on the other side, you have hard determinism, where we are, oh yeah, good point, not Calvinism, but that's predestination, not determinism. So I'll talk about determinism, then I'll talk about Calvinism. But yeah, when you're determined in the same way that the behavior of billiard balls on a table is determined, or the same way that the behavior of all the elementary particles in the universe are determined. You're determined by the laws of nature. You know, like this is like Laplace, right? Pierre de Laplace, when asked by Napoleon why he did not include any mention of God in his book on physics and astronomy, Laplace replied, "I have no need of that hypothesis," because he doesn't have any explanatory work to do. This is actually mentioned in the previous chapter, this little example, although we didn't really talk about it too much. So that's determinism. Slightly, I mean, predestination is yeah, Calvinism, right? So I believe Calvin's exact words were God saves and God damns. So God's already decided before you live your life kind of whether you're going to be good or evil. And if he's decided you're destined to be a good person, great, you get to go to heaven. But if God made you to be evil, you are not going to go to heaven. You'll go to hell. But it's because God made you that way. It's kind of messed up, if you ask me. But I'm not religious, so maybe I'm a little biased against predestination. In the middle, you have compatibilism, or soft determinism, where we are free in the sense that we could always have done otherwise. And that's the sense in which we are free if we are probabilistic Turing machines as well. So Michael asks, could Turing machine states table be represented by the 100 trillion connections between the 80 plus billion neurons in the brain? Maybe. I mean, there's some debate on this, whether things like neural networks, which our brain is just a big, giant natural example of, there's some debate on whether those are actually different than symbol systems. If they're not that different, then sure, probably. In principle, I would say it's possible. Maybe it's not actually possible. Maybe it's as a matter of feasibility or practicality, maybe it's not possible. But in principle, it might be possible. Okay, so little digression on freedom of the will for those who are interested. And again, we will talk about this more when we get into the chapter on mental causation, which, if I'm not mistaken, is what we'll be looking at on Wednesday. So machine functionalism escapes the worry of circularity by appealing to the Turing machine. Aldwin says, so a probabilistic Turing machine allows us to explain the reliance of a mental state on other mental states and so forth. Does that mean that the strongest mental state with the most support from other mental states will decide what mental state everything will be acted on? Well, I wouldn't say that it's like quite like how you've put it, but there are some thinkers who we call foundationalists, that think that our cognitive system is kind of built up from fundamental states, fundamental beliefs that are indubitable and incorrigible. Like Descartes, for example, his cogito, right? I think, therefore I am, is kind of like an epistemic foundation or bedrock upon which everything else is built back up. So those would be like those foundational states would be the strong ones if you're a foundationalist. But on the other side of the debate, you also have the coherentists. And they say that there isn't really a fundamental or a principal set of mental states. Everything actually kind of hangs together, kind of like how a spider web hangs together. So, it really depends if you're, I guess I would say it depends whether you're a foundationalist or a coherentist. Okay, so causal theoretical functionalism exploits the causal relations involving all the states in the system, all of the mental states, to escape the worry of circularity. And we're going to look at how it does this today. And I apologize in advance for how tricky this is. Well, I apologize. I didn't write the book, but I guess I chose the book. So sorry if this gave you a headache. Let's try and come up with a theory of pain following Kim. So this is a theory of pain, a sort of toy theory of pain that Kim comes up with. And this is what it says. Our theory is T. It states that for any X, if X suffers tissue damage and is normally alert, X is in pain. If X is awake, X tends to be normally alert. And if X is in pain, X winces and groans and goes into a state of distress. If X is not normally alert, or X is in a state of distress, X tends to make more typing errors. Now let's look closely at what's going on here. Because this is a theory, T is a theory, we want it to describe causal relations. And these causal relations are going to be law-like relations, governed by things like the laws of nature or the laws of logic, right? What the italics describe here are non-mental predicates, and they designate some observable properties. They could be physical, biological, and behavioral properties. So suffering tissue damage is an observable property, right? It's an observable physical property. I can see, oh, so-and-so has a cut or a bruise. That's tissue damage. Likewise, if you're awake, X, by the way, is our person. So if X is awake, well, I can tell biologically and behaviorally, you'll be up and about and your eyes will be open instead of lying down with your eyes closed, breathing slowly, right? Wincing and groaning, that's a pain behavior. Making more typing errors. If I'm in pain or a state of distress rather, or I'm not normally alert, I might tend to make typing errors. In fact, I've noticed this because I got this new computer last year and I'm still not used to the larger keyboard. And if I'm sleepy, I'm worse with it, right? You can also imagine that if you were in distress, you would be poorer at typing. This is just an example, though, right? There could be any other a number of other behaviors that might occur if you are in distress or if you are not normally alert, right? Yeah, it goes to show you, Jack. So Jack got a new laptop and he relates. It really goes to show you, like muscle memory and stuff, or those unconscious automatic processes that we don't realize are so unconscious until we get a new device and we have to adapt, right? Or if you're used to, I mean, alert is observable, but the bold font describes psychological predicates. So, Michael, that's a good question. Alert isn't in italics because it describes psychological predicates that designate mental properties. So these are not directly observable, whereas what's in italics are non-mental observable predicates. So that's why there's that difference. But yeah, Jack, it shows the difference. Like, okay, so this was the example, right? Sometimes I'll play a video game, right? I'll be playing some, I don't know. I should be playing Detroit Become Human, is what I should be playing. But I'm actually replaying Mass Effect because I'm a giant nerd. And I play it on my PlayStation, right? So I'm do. And then later that day, get online on the Switch and play some games on the Nintendo Switch, and you have to kind of remember where your action button is, right? Now I can kind of switch effortlessly, but previously it would throw me off because, as you know, if you're a nerd like me, Nintendo and PlayStation, the action buttons are different, right? So really highlights that the automaticity of being, if you like. So let's move on. So yeah, like I was saying to Michael there, the italics describe non-mental predicates that designate things we can observe, and the bold font describes psychological predicates. These designate our mental properties. So being normally alert, being in pain, being in a state of distress, those are mental properties. Now, again, this is a toy theory. It's obviously not an exhaustive or complete theory, but it serves to illustrate something that Kim wants to show us. This is called the Ramsey-Lewis method. It's named after a mathematician philosopher named Frank Ramsey, and it was developed by David Lewis, further developed by David Lewis. And it's a sort of logical method for existentially generalizing over a theory like T. Oh, yeah, Jacob. Yeah. For the whole trilogy? $10? What a steal. I bought the legendary edition on I like to have a physical copy, so I got it on disc, right? But oh man, that's like my favorite game. Mass Effect 2, am I right? Like, oh man, that's the suicide mission. Oh my god, I could play that over and over forever. It's so fun. Anyway, we don't want to nerd out too much. But yeah, that's your homework. If you ever see a great AAA game like that for $10, you gotta get that. So we're gonna Ramseyfy our theory, T. And remember, T is this sort of ordinary language, sort of, well, it's not exactly ordinary language, but this sort of theory that describes pain. Like if I'm an X, if I suffer tissue damage and I'm normally alert, I'll be in pain. If I'm awake, I tend to be normally alert. So if I'm in pain, I will, wince and groan and become distressed, etc., etc. We're formalizing it by existentially generalizing over all of our psychological predicates that we find in T. So we get TR, T for a Ramseyfied version of T. And TR states that there exists states M1, M2, and M3 such that for any X, if X suffers tissue damage and is in M1, X is in M2. If X is awake, X tends to be in M1. If X is in M2, X winces and groans and goes into M3. And if X is either not in M1 or is in M3, X tends to make more typing errors. So what's the difference between T and TR? T, you'll recall, refers to specific mental states, but TR refers to some state or another. M1, M2, M3 are variables. In fact, we call them predicate variables. All these states, M1, M2, and 3, are related to one another, and they're also related to the same observable behaviors that are specified in T, which we also find here: suffering tissue damage, wincing and groaning, etc. So these predicate variables are topic neutral. They're like the X's and Y's in mathematics, right? They can mean whatever we want them to mean. Here, M1 just means is normally alert, M2 means is in pain, and M3 means is in a state of distress. So we can kind of generalize this by taking our statements from T. We'll just go back. Normally alert, in pain, state of distress, which are predicate constants, actual predicates. These would be like numbers in a mathematical theorem or a mathematical formula. We can take those and we can existentially generalize them by saying there just is some set of mental states like M1, M2, M3, and we can have those mean whatever we want. That's why these are variables. So M1, M2, M3 here are variables, but normally alert, in pain, state of distress, etc., those are predicate constants. You see the difference? Like, imagine if you were to calculate this the speed at which something dropped from a certain height would hit the ground, right? Um, anyone do this in a physics class? Maybe you have some familiarity with this. Well, if you do this, you're going to have to employ the gravitational constant, which on Earth is going to have a particular value. I forget what it is. G on Earth, it's maybe someone can Google this, what the gravitational constant is. But your variables might be the mass of the object that you're dropping and the height that you're dropping it from. Those can change depending on what you're dropping and where you're dropping it from. But G is not going to change, right? 9.81. I knew it was 9 something. So this is like that, right? Our variables, our predicate variables are, whatever we want them to be. But when we actually but in t rather than tr, we're dealing with constants rather than variables. So is everybody following what's happening here so far? What we're doing by existentially generalizing over these predicates? Okay, good. Jack says yes. Hopefully everyone else agrees. Taylor's trying. Don't worry. If there's anything unclear now, we should deal with it because the next slide is a doozy. Okay. So if we're not sure, please ask me now before we go ahead. Really, like what we're doing, remember the whole point of formalizing something? Yeah, it's just formal logic. And like, I get it. I'm not a logician. Like, this is not what I do, right? I'm a plain language kind of guy, right? So this is not my forte, but it's not as hard as it looks. But Jack mentions formal logic. When we formalize something, we make it abstract. Remember? So this is what we're doing. This is concrete, right? If there's an X, like say I'm X, if I suffer tissue damage and I'm normally alert, then I will be in pain. It's describing these law-like relations between inputs and outputs. So we've got inputs, tissue damage, a mediating mental state, and an output, which is another mental state. This is concrete, though. By formalizing it, by existentially generalizing it, we make it abstract. So instead of predicate constants, we have our predicate variables. Just making things abstract, that's all we're doing. You can also think of it like this, right? Like you can have a deductive syllogism like all A's are B's, X is an A, therefore X is B. That's abstract. But you can plug in whatever you want, right? All men are mortal. Socrates is a man, therefore Socrates is mortal. Right? Or if you've taken an introduction to logic class, you've no doubt talked about the deductive syllogism. You've probably talked about modus ponens and modus tollens, right? And they have they have like a sort of formal form, right? If P then Q, etc., etc. Those are just variables. So it's formal because it's abstract, but we can make those variables mean whatever we want. That's all we're doing here. And we're doing it for a functionalist theory of pain. Now we're getting into the doozy stuff. So Ramsey showed that TR is weaker than T. It's just as powerful in terms of its behavioral prediction. So we can existentially generalize T as TR. They make the same deductive connections between non-psychological statements. So now we can get rid of our circularity worry. We'll abbreviate TR the following way. And this backwards capital E, that's the existential quantifier. That means there exists. So TR, we can turn it into this. There exists these mental states, M1, M2, M3. And our theory has M1, M2, M3. So then we can define pain like this. X is in pain. Definitions, there exists mental states M1, M2, M3. Remember, these mean is awake, is in pain, and is in a state of distress, such that on our theory, we have these three mental states, M1, M2, M3. We have a theory where we have being in pain, being normally alert, being in pain, and being in distress, and X is in M2. That means that X is in pain. So that's how we define pain. Maybe I can annotate this, right? So what does it mean to say that X is in pain? Well, remember, definitions, there exist these three mental states. Normally alert, being in pain, being in distress. And this T indicates that on our theory, our X can be in one of these three mental states, but X is in M2, so X is in pain. And we can do that for all the other variables, right? So let's get rid of my, how do I clear this? Clear all drawings. Go to the next slide. So here we can define normally alert. X is normally alert, just in case there exists these mental states. And on our theory, X is in M1. Likewise with distress, we have all of our mental states. There exists mental state being normally alert, being in pain, and being in distress. And X is in state M3, which is a variable that we've decided means X is in distress. So you probably have a headache. In logical language, you're in X and you're in M2, which remember means that you're in a state of pain. So what does all this say in plain language? As Kim says, it says that you are in pain just in case there are certain states, M1, M2, and M3, that are related among themselves and which, with such physical behavioral states as tissue damage, wincing and groaning, and typing performances, as specified in TR, and you are in M2. Taylor, go ahead.
Yeah, just a quick question. Can you hear me okay?
I can.
Okay, so on the top there it says X is normally alert. Okay, so X means normally alert, right?
X is you. X
Oh,
X
X, okay.
yeah, X is the system, the agent, the person.
Oh, okay, that makes sense. And then
Yeah.
what does it mean when it says, so I get all of this except X is in M1? How can X be in M1? Maybe I missed something there.
So what this is defined what's on the right hand side is our definition of what it means for X to be normally alert. It just means that there exist these mental states that are causally related to each other. So being normally alert, being in pain, and being in distress. And so our theory specifies that out of these states that exist, they're all causally related to one another. And right now, X is in M1. So like the equal sign, it just says that what's on this side right here is defined thusly, like with this, logically. That's all it means. It looks a lot more complicated than it is. Oh, good. Okay, well, lots of questions. Okay, let's get rid of the things. Okay, so right, def means definitions. And it just means, like I was saying, Aldwin, it just means that if you were to ask, what does it mean for X to be normally alert? Well, here's a theory that explains what it means for X to be normally alert given in predicate logic. That's all it means, right? If extended, Jack says, is T a set meant to exhaustively show the mental states? I guess if we it's not exhaustive the way it's put here, right? Because it's a toy theory. But the idea is that we could, in principle, exhaustively include all of the sets that are the set of all mental states is the idea. That is the idea. Is that what you're asking? I just want to make sure I'm answering the right question. Because remember, I'm actually not a logician, right? So I don't want to steer you wrong. Taylor's getting it. That's good. Well, this is just so our theory right now is just for pain, but the idea is that our theory of the mental would in principle include all mental states and all the causal relations, kind of like I guess if you've read Quine, right? Like how the mind is a whole propositional attitude system kind of thing, like so if you haven't read Quine, don't worry about it. We're not really. Hey, it's kind of is Quine even in this textbook? I think he might be in the next chapter. I don't remember. Don't worry about it. Why? So Hiley asks, why would they be in pain or distress just because they are normally alert? Well, I think that's specified that way because sometimes like when you're busy and you don't notice that you've hurt yourself, and you don't feel the pain until your attention is freed up. Like, sometimes I used to work at a restaurant. So yeah, or you could be sedated too. Like if you're not like say you're undergoing surgery, right? You're going to be anesthetized. So you're not normally alert and there's tissue damage, but you don't feel the pain because you're unconscious, right? Or like I was saying, if you are distracted, so like I used to work at a restaurant. It was it rhymes with Flim Flortons, and I'd be slinging coffee and making sandwiches. Sometimes I'd hurt myself, you get a little cut or a scratch, but I'd be so busy that I wouldn't notice until after. And then you have to be like, oh, geez, I've cut myself. I got to go put a band-aid on and put a glove on and blah, 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 right? You get distracted, you don't notice. So that's what that normally alert um, thing is there to do, right? Yeah, and mysterious bruises, sometimes you're like, how did I get that? Right. And barring, like you're not a hemophiliac or anything. But yeah, that happens to me too. I'm like, oh, when the heck did I do that? I don't remember. Must have been busy. Yeah, it's the worst. I mean, I don't want to knock them, but I agree with Jack. Well, actually, Jack didn't say that. I'm saying this, but it was in fact the worst job I have ever had, and I was a garbage man. Okay, like and it was actually pretty great because loads of physical activity. You're outside. You can keep whatever you want. So that was great. Then from there, went to college, did some Tim Hortons, Flim Flortons, then again in grad school. And man, it's just so much time that I can never get back. So yeah. Anyway, it's much better to do philosophy than to sling coffee. Yeah, understaffed. Do you know the one I worked at? Okay, so sorry for the digression, but come on, we need to make things fun. But does anyone remember the one in Ottawa by King Edward and St. Patrick? Anyone ever been? It's like right in Lower Town. Taylor knows that. So that's the one that I used to work at. Yeah. Okay. Oh, it's not far from my old place. Yeah. So you guys know if you know the locals they called it the block. Like the clients at the shelter, that's the block, right? And it was certainly a thing. Well, a lot of the clients at the homeless shelter, they were actually my best customers. They were really nice most of the time. It was the people on their way to work rushing in the morning that were grumpy. But the people from the shelter, by and large were great. They just, you know, sometimes you'd have to tell them not to do drugs in the store and kick them out, right? But yeah. Yeah. So I hope I haven't given you a headache. Maybe my little Flim Flortons digression has alleviated your pain. But to reiterate, all of this sounds really complicated if you're not used to predicate logic, right? But all it says is just that there are these certain states, there are predicate variables, M1, M2, and M3, and they're related among themselves and with such behavioral states or physical states like tissue damage and wincing and groaning, etc., as specified in TR, and that you're in M2. You are in a state of pain. So now we have a theory of pain where mental states feature as causes and effects, and they're all interdefined, just like how on Turing machine functionalism, all the states are interdefined in the machine table. In causal theoretical functionalism, we're just doing it with predicate logic. So there's no circularity because everything is interdefined. Okay, hard part's over. That's the worst part of the chapter. Worst. It's not the worst. That's the most difficult part for the uninitiated in logic. It gets easier now. Now, Kim says, we can think of the Turing machine approach as a special case of the Ramsey-Lewis method in which the psychological theory is presented in the form of a Turing machine table with the internal machine states, the cues that we saw in our machine table from the last chapter, corresponding to the predicate variables, the M's in our Ramsey-fied version of TR. Do you see? Do you understand? There's two things happening here, right? The Turing machine approach is doing the exact same thing as the Ramsey-Lewis method is doing with TR. We're just doing it with a different formal system. We're doing it with a machine table, something analogous to a computer program. But on the Ramsey-Lewis method, what we're doing is we're using a logical language. But they're both formal systems. And indeed, you could argue that this approach is even more formal than that of a Turing machine. So that's one thing that's going on. In either case, though, another important thing to take note of is that they're pretty straightforwardly functionalist, right? Because they're defining what it is for a mental state to be a mental state in relation to inputs and outputs, and also in relation to all of the other mental states. And remember, these relations are causal. That is so important to remember. All of these states are causal. In the case of a Turing machine, algorithms cause the machine, given its inputs and its current state, to move to the next state, right? Likewise with humans, if we are indeed Turing machines, tissue damage will cause me, if I am normally alert, to experience pain, which will further cause me to behave in a painy sort of way, going ouch and withdrawing my hand from the painful stimulus, for example. Everyone clear on that? Of course, if you're not clear, feel free to say so. Awesome, Taylor. Well, don't sell yourself short. I mean, like I said, if you've not done this before, it can look really intimidating. But really all this is just saying, all of this is just stating in a formal language, predicate logic, what it means for someone to be in pain or to be normally alert or to be in distress. Mental notation. I like that, Aldwin. Yeah, you could think of it like that, right? And yeah, Jack has a good point. Philosophy of mind is really just metaphysics and logic in disguise. Kind of, I would say. It's like it does have a lot of that applied specifically to the mental, right? So, and that's fun. I like it. I don't really do a lot of the logic stuff because I'm a very empirically oriented person, right? Like my PhD is not in philosophy. My PhD is in cognitive science. But I think to be a good cognitive scientist, you really need to be philosophically literate. And for that matter, to be a good philosopher, you also need to be scientifically literate. So I guess I'm a jack of all trades, master of none, right? But Jack is right. You know, there's a lot of that there. So, how do we choose an underlying psychology? We want an underlying psychology for our theory, right? Our theory needs to explain all psychological states beyond pain. So it's got to encapsulate enough information about each state, right? All of its input-output relations and relations to other mental state in order that we can identify and define each state. So what theory should we choose? Option number one is common sense psychology, which we also sometimes call folk psychology. That's my preferred term. Propositional attitude psychology, belief desire psychology. There's all kinds of terms for this. This we've talked about this before, right? This is the way that we make sense of the things other people say and do in our everyday lives. This is the way we make sense of other people's behavior, the way we theorize about other people's behavior, at least according to certain thinkers, right? Think back to when we learned about the desire, belief, action principle, right? If our subject desires A and believes that B will bring about A, then she will do A, right? If my roommate believes that it's going to rain and desires to stay dry, then she'll take her umbrella, right? That's folk psychology. And the idea is that, at least according to some, that when we're doing this, what we're doing is analogous to theorizing. So have you heard of theory of mind? Have you guys all heard that term before, theory of mind? How about who hasn't heard of theory of mind? Taylor has not heard of it. Anyone else unfamiliar with theory of mind? Aldwin also. Anthony, okay. Thomas, Sohaila, sorry. Blah, blah, blah. Angelica, go ahead.
Oh, no, I was just saying that I'm unfamiliar with theory of
Oh,
mind.
I see. Sorry. Yes, well, so it's the idea that yeah, what we're doing is kind of putting together a theory to explain and predict behavior, almost like we're little scientists when it comes to understanding other people. It may not be how folk psychology works. We might simulate by imagining that we're in the other person's shoes or that we are literally the other person. So we might simulate, but we might also theorize, right? And in order to theorize, we have to be able to attribute beliefs, desires, and other mental states to people. Yeah, like Aldwin says, predicting people's intentions based on their actions, it can work that way too. Like, why did someone behave that way, right? Like if I asked you, this is from an old computer script from a guy called Shank from the 1970s, but like, you know, I would tell a story, try and get a computer program to answer questions correctly. Like a guy goes into a restaurant, orders a hamburger. Shortly after he leaves, he hasn't finished the hamburger and he hasn't left a tip. Did he like the hamburger? And the right answer is no, he didn't enjoy the hamburger. He didn't leave a tip and he'd left without finishing his meal. So we can work out that, well, he must not have liked the hamburger, right? Or maybe he's broke and he can't afford to tip. But in that case, I think he should have certainly eaten the entire hamburger. Yeah, we could also say that he had an emergency, but this example is from before the age of cell phones and pagers. So, yeah. But you're right. I mean, there are any number of other considerations that we could bring to bear on this, right? But the point is that they would always be some combination of mental states to explain his behavior. Either he didn't like the burger, or he believed that there was an emergency. Maybe there was a car crash outside, and he's a doctor. So he's got to run out and make sure that no one needs medical attention, or provide aid if they do require medical attention, right? The point is, it's always another set of mental states, right? It's also the kind of thing that the false belief task tests. Sometimes that's called the Sally Ann test. If Sally comes in and she has a marble and she puts it in box number 1, she leaves the room. Then Anne comes in and secretly, without Sally knowing, moves the marble to box number 2. When Sally comes back, which box will she look at? People with reasonably well-developed theory of mind will correctly say that she'll look in box number 1, where the marble isn't. But people who have deficits in theory of mind, for example, some children on the autism spectrum, they'll say that that she'll look in box number 2 because they don't realize that Sally doesn't know where what they know, right? The kids know that the marble's been moved, but Sally doesn't know that, and the kids don't know that she doesn't know that, right? So that's something you see in it's kind of been, I think it's kind of been overblown. It's kind of almost, the way this is talked about makes it seem like autistic people don't have a theory of mind at all, and that's not true. But some kids on the spectrum will be like a little bit delayed in crossing that milestone, right? It also depends on whether the test is linguistically formatted or whether it's shown to them. Like, there's all kinds of considerations. But the point is that that test illustrates theorizing about other people's mental states, right? If we go with this option, we would call it analytical functionalism, if we were to use common sense psychology as our underlying theory. But it's not the only option. Another option is scientific psychology. That is what people like me do. Cognitive scientists, psychologists, etc. We formulate precise theories that explain these causal relations between inputs like our perceptions or other mental states and outputs like behaviors or yet other mental states. And if we pick this option, we would be doing psychofunctionalism. Now, we better make sure the one we pick is correct. Kim goes through some of the strengths and weaknesses of each. The point he wants to make, though, is that if our underlying theory is false, then anything that we try to generalize from it by employing the Ramsey-Lewis method will also be false. So we want to make sure we pick the right one. So we ought to discuss some strengths and weaknesses of both common sense psychology and folk psychology. Now, before we do that, I believe we are about halfway through. Yes. And when we come back, we're going to be talking about some interesting thought experiments again. So who would like to take a 10-minute break? This is always when the chat blows up. Yes. Oh, so Hyla, that's an interesting thing. I'll share my thoughts on that before we go to the break. So here's how I understand philosophy. Philosophy is for answering conceptual questions, for answering fundamental questions, like not even theoretical questions, but pre-theoretical questions. Philosophy is for metaphysics and epistemology, for working out what things are like, what things exist, what are they like, for working out how we know things and how we know when we know things. Once you have that philosophical bedrock, then you can go and do science. But philosophy and science should not be opposed to one another. for most of the history of philosophy, science just was philosophy. They were the same thing. There was no difference. It's only in the last few hundred years that the difference seemed to emerge. And yeah, philosophy is also for, like Aldwin says, you know, I won't say the meaning of life, but meaning in life, you know, understanding what the good life is and how to achieve it. That's also a philosophical project. That's something that science isn't going to really help you with unless you already have philosophical commitments, right? So science and philosophy are different, but you could say they're opposites in terms of what their jobs are, but I don't think that they're opposites in that they're opposed to one another. So that's what I would say. Are there any other questions about any of the material that we've covered so far before we start our break? Okay. So why don't we come back, let's see, at 3:45-ish, and we'll resume, and we will cover the rest of the material. We'll get to some fun thought experiments like inverted qualia and the cross-wired brain. So, remember we were considering an underlying theory. We could go with folk psychology on the one hand, or with scientific psychology on the other. So that is analytic functionalism or psychofunctionalism, respectively. So let's say we go with psychofunctionalism. Let's say we go with scientific psychology. We have to assume that our psychological theories posit internal states. So we're not going with a behaviorist approach, and that these states systematize our correlations between sensory inputs and behavioral outputs. So we'll have our subject S, and she behaves in such and such a way. We might have two psychological theories, T1 and T2, and they might each explain S's behavior. And T1 and T2 posit wholly different inner states, therefore wholly different causal chains that get us from our inputs to our outputs. And both of them explain S's behavior equally well. So if we want to Ramseyfy one of these theories, choosing the correct one matters. But which one is correct if they're both behaviorally adequate psychologies? See the problem? How do we know which one's correct if they both describe S's behavior perfectly well, right? That's a problem because we don't know which one's correct. How do we find out which one's correct? Consider what Kim says about Turing machine functionalism here. There are internal physical states of S that realize the internal machine states of the Turing machine in question. That is, there are in S real internal physical states that are causally related to each other and to sensory inputs and behavioral outputs as specified by the machine table of the Turing machine. It is the requirement of physical realization that answers the question of the psychological reality of Turing machines purporting to specify the psychologies of a subject. So our correct theory will be whatever theory picks out the real internal states of S, the real states of the Turing machine. The correct theory, in other words, will be the one that can describe how S's mental states are actually physically realized. So then we get something like this premise or this principle. The states that the Ramseyfied psychological theory, TR, affirms to exist are physical neural states. That is, the variables M1, M2, and so on of TR, and in the definitions of specific mental states, so our examples that we went over earlier, range over physical neural states of the subjects of psychological theory T. So that's how we can know which theory, T1 or T2, is correct. If they both describe the behavior equally well, we want one that not only describes the behavior equally well, but one which also captures how the internal states are physically realized. And this is what psychologists and cognitive scientists actually do. Think about it. Actually, can anyone think of an example? So we've got competing theories about how some cognitive process works. They both explain our observational data equally well. How do we know which one's right? See if anyone can offer an example. And it can be an imaginary example. It doesn't have to be a concrete one, just for example's sake, right? What would you do if you were a psychologist and you were trying to decide between two theories that explain behavior equally well, and you wanted to know which one is actually explaining what's going on in here? Keyword, in here. Keywords. Aldwin says, experiments. Yes, you're right. But what kind? Jack adds, look in here. Yeah, you have to look and see. So, well, you could ask the individuals, but they don't necessarily have the right kind of introspective access. Neuroscience. Yeah. You want to decide between competing psychological theories? Try and figure out how all of it is realized in the brain. And to do that, you might do some functional neuroscience or something and look at brains as they're actually doing a task in like under a functional MRI machine or something. And you can see what's doing what, when it's doing what. And then you can decide, okay, it's theory one, not theory two. Because when we look in the brain, we can see, okay, these are the steps that are actually being realized, the steps described in T1, not T2. So that's what we do. That's what cognitive scientists actually do. I didn't talk about some of the problems with folk psychology, but we can do that now before getting to the objections and difficulties. So one problem with folk psychology is that it's folk, right? Think of it like this. We all have a sort of rudimentary folk physics, right? We understand how objects in the world tend to behave. I have a sort of folk physics, I understand intuitively that if I drop this pen, it will fall, right? If I let go of it, well, it's going to go down. It never happens that I let go of it and it goes up. No, I drop it and it goes down. So folk physics, right? I can understand that solid objects are not going to pass through one another. So I can't like mash these writing implements through one another. I can't push them through a desk, right? So I have this sort of folk psychology or folk understanding of mass and solidity and gravity and different things like that, right? And that's fine. That helps me get on in the world. But it is not as accurate or predictive as like actual physics, right? Like if you're standing on the Leaning Tower, like pretend you're Galileo and you go up to, wherever, the Leaning Tower of Pisa or something, and you drop a small stone and a heavy cannonball. The prevailing folk physics at the time had it that the cannonball would hit the ground sooner, but that's not what happens, right? They actually hit the ground at the same time. Scientists have even done this experiment on the moon. On one of the lunar missions, one of the experiments that was recorded and broadcast to people on the planet Earth was dropping a hammer and a feather at the same time. And because there's no atmosphere on the moon, we don't have to worry about, resistance from the air or something. And what happens is the feather and the hammer hit the surface of the moon at the exact same time. So, and with scientific physics, you can predict exactly how everything is going to behave. Using, your theory of gravitation, your gravitational constants, and blah, 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 blah. So it's more precise than folk psychology. Yeah, so Hyla, that's exactly right. That's a trick question. You ever get that question where it's like, which is heavier, a kilogram of feathers or a kilogram of iron? Well, they're the same weight, obviously, right? But a lot of people will answer that the iron is heavier, even though it tells you the answer in the question, right? They both weigh 1 kilogram. Yeah, exactly. Another reason to be worried about folk psychology is that, like the eliminativists, the eliminativists say that mentalistic terms like beliefs and desires are not real. They should be reduced to more fundamental states, like beliefs and desires can be reduced to brain states, and then we can eliminate our talk of beliefs and desires. Paul and Patricia Churchland go so far as to say that we got to get rid of our mentalistic talk. It will go the way of things like phlogiston or the luminiferous ether or elan vital, right? The vital principle that explained life before we knew about evolution and DNA and metabolism and all that stuff, right? We don't need phlogiston to explain heat, and it turns out it doesn't exist. We don't need the luminiferous ether to explain how light propagates through space. We don't need elan vital to explain life. We don't need beliefs and desires to explain mentality, because we can just reduce it all to physical stuff. That's another problem. Counter arguments that Kim offers, well, folk psychology is pretty powerful. Even though it's not as precise as scientific psychology, it is because of folk psychology that I can understand the plight of a character in a Greek tragedy or in an ancient Chinese novel or anything like that. I'm separated by thousands of miles and thousands of years from, the characters in Greek tragedy, but I can still feel for them. And that's because of folk psychology. So it's pretty powerful. So that's all we'll say about folk psychology and scientific psychology. Who has any further thoughts they might like to offer? I mean, are we skeptical of folk psychology, or do we think maybe it has a job to do? Should we eliminate it? Should we eliminate our mentalistic terms altogether, like the eliminativists say? Or should we keep them? Yeah, Taylor says, I think it has a job to do. Jack says, without folk psychology, communication would be hard. Certainly. And so Hyla says both are important. I agree. Our imaginations might die. Yeah. Well, I think like Hyla says, they're important, because they're a higher level description of human beings, or mental states and folk psychology, right? Higher level descriptions are important. Like, I need to understand, I can't just talk about atoms or molecules if I want to understand what a chair or a table is. I have to talk at the level of tables and chairs, right? Because fundamentally, if everything is just matter and energy, then how do I differentiate between all the things that exist at higher levels of analysis, right? And yeah, communication would be awfully hard. Even skeptics of mental states and folk psychology, if they go to recruit people for an experiment, they'll still put up a sign that says, come and participate in the experiment, you'll get $10, because they're banking on people believing that if they go and do it, they'll actually get $10, and they desire to get $10. Like, so there's broader questions, Jack says, about whether we should reduce higher level facts to lower level facts, and if meaning still remains. Yeah, there is. Yeah. You know, reduction is fine, but I don't think we ought to eliminate mentalistic talk. That's my take on it. Like, yeah, there's going to be cases where I want to understand what's going on in terms of neurons and neural networks in the human brain, but there's also times when I want to know what someone believes or desires, right? Yeah, ethics maybe. It's certainly scientific psychology has gotten a lot better, ethically speaking. We're no longer doing like Milgram stuff or Stanford prison experiments. Not going to get that through ethics today. I imagine that. I write my ethics proposal. Okay, so I'm going to make someone believe that they've shocked a man to death. Can I do my experiment? Nope, sorry, you can't. But in the 60s, you could. Or little Albert, right? We talked about little Albert. Hey, I'm going to make this kid afraid of fuzzy bunny rabbits just because I can. How will it affect him later in life? Don't worry about it. So yeah, psychology's gotten a bit better, but yeah, you're right. Let's talk about some objections and difficulties to functionalism, not just causal theoretical functionalism, but also Turing machine functionalism. One is qualia inversion. So functionalism doesn't really deal with qualia. You know, these subjective, qualitative, phenomenal features of our conscious experience. So like these colors on the visible spectrum of light, they're all different. There's something that it's like to look at red. And orange is a bit different. Yellow is a bit different from that. And green is different from violet and indigo and blue. Well, something that it's like to look at blue, which is different than what it's like to experience redness. These are quale. The quale of red is different from the quale of blue. The inverted spectrum thought experiment shows us how functionalism fails to really deal with qualia. Imagine that some of us have an inverted spectrum. So we flip this. Imagine that this is flipped. So I see red when I get, wavelengths of light that are about 700 nanometers hitting my retina. That causes a visual experience of red in me. But you have an inverted spectrum. So when you see light that's got a wavelength of 700 nanometers, you see violet. But because our spectra are inverted, we can talk about this and not have any idea that we have different internal experiences, different private mental experiences. It's like the beetle in the box all over again, right? When I look at 700 nanometers of light reflecting off a surface, I see this color and I call it red. You see this color and call it red. And we can talk about red things perfectly consistently, like, look at that red car over there. Oh, yes, I see it. I see this color. You see this color. We have no idea of the difference. Now, because functionalism talks about input-output relations and the causal relations of internal states and, how all of that is related to everything else, it can't deal with this. What if there were an inverted spectrum case? That would be an obvious difference in private mental states that functionalism wouldn't be able to tell us anything about. Really, Taylor? What do you mean? Can you explain?
Yeah, my husband has a pair of shorts, and I would kept calling them, oh, like your blue shorts. Like I kept saying, let's watch those blue shorts or whatever. And he didn't know what shorts I was talking about because he sees them in green. And then he wore them yesterday, and we sat there going for a walk arguing about how when I look at his shorts, I see blue. And when he looks at his shorts, he sees green. And then we started comparing the shorts to what other people were wearing around us, and I said that these shorts are the same color as that little girl's t-shirt over there, and her shirt was blue. And he was like, no, they're not. So it's like, I don't know, it was weird.
Can I ask, is your husband colorblind?
I hope not, because he's a painter. So
Maybe he's distinguishing colors differently because he's a painter.
Perhaps, yeah, it could.
Yeah.
I don't know. It's very interesting though. And he had an eye surgery when he was really young on both his eyes. So I wonder,
Oh,
like, I don't know, maybe he's enlightened.
maybe. And so humans typically have could it be similar to the dress? Yeah, good question. Maybe, but that also has to do with different lighting conditions. So yeah, it might be, but I'm skeptical of that because if you're outside in the sun and yeah. So I don't think it'd be quite like the dress. Um, so color expertise is a possible explanation. Color blindness is a possible explanation. Another explanation is that most humans have three types of cones, for detecting red, green, and red, green, and yellow, right? Yeah, maybe it's you, Taylor. That's what I'm saying. Some women, for some reason, this happens with women, rarely will have a fourth cone. Not all women, but some small percentage of women actually have a fourth cone and can detect colors that other people can't. Perhaps you have a fourth cone, Taylor. I'm not sure. But in any case, that's interesting. But yeah, the inverted spectrum would be not if green is blue, et cetera, but if the entire thing was flipped so that red is violet, indigo is orange, blue is yellow, and then the two shades of green are inverted. Functionalism would have nothing to say. Yeah, I mean, it really would be like a superpower. And yeah, some people, for some reason, they have this mutation where they have a fourth cone and a fourth type of cone, and they can just see further. I believe it's further into the violet end of the spectrum that they can see further into. But it also depends on color, like it can also be culturally dependent as well. Like some people in certain cultures just talk about colors differently. So we just categorize colors differently, right? Like we tend to think of the sky and the sea. The sea is blue, right? We would say the sea is blue. The ancient Greeks called it wine dark. The sea was wine dark. In Homer, you hear it described that way. But you say that to us, and you're like, "What? That doesn't look like wine. What are you talking about?" Right? So we also might conceptualize colors differently. Qualia could even be absent, right? So here comes the obligatory Star Trek reference. If you have a character like Commander Data from Star Trek: The Next Generation, right? He, I mean, Kim characterizes this as a case of absent qualia. I would say I say Data is phenomenally impoverished, right? Data doesn't feel emotions. He doesn't feel pain, right? He doesn't experience hunger because he's an android. So how would we deal with absent qualia? Or philosophical zombies would be another example. All is dark inside, right? Um, these pose problems for functionalism. How exactly? Well, a function like again, a functionalist has nothing to say about qualia. How would he reply? He might say, my mental state M is realized by a neural state P. We cannot differ with respect to qualia if we are in the same neural state, but that doesn't really address the problem. What if because again, multiple realizability, we might be talking about physically different neural systems, like other kinds of non-human animals or aliens from other worlds. And you could say, oh, maybe qualia supervene on the physical neural states that realize those mental states, but that's also a problem. Because how does that work? We'll come back to these in our chapters on consciousness. But what do you all think of qualia inversion or absent qualia? Do you see how, just without inversion, I mean, inversion and absent qualia highlight the problem, but right off the bat, right out of the gate, functionalism doesn't say anything about qualia at all. You see? Yeah, it's a big headache for physicalism. It's what David Chalmers calls the hard problem, right? And it's really connected to the mind-body problem, right? Like, why is red red and not some other color? Why is pain painful and not some other sensation, like an itch, right? Why? Why does coffee smell the way it does and not something else? Well, you can say God, but that's not an answer. If that's the answer, then why not save a step and just, like, if you're going to say that's just the way God did it, then why not just remove that and say, well, it's just the way it is. It's a brute fact or a primitive notion, right? We'd be violating Occam's razor if we said God did it, is what I'm saying. Yeah, well, we defined it. Well, no, Michael, because the inverted spectrum still is there. Like, red is this color. Well, but if you have an inverted spectrum, we have different qualia of red. Yours is my violet, and mine is my red. So it's not even interdefined in a community of speakers, because we each have different, we have different beetles in our boxes, and we talk about our beetles like, that's a red, but I have a red beetle and you have a purple one, right? And we don't know that we have different beetles in our boxes. Yeah, qualia is hugely important. Our consciousness, our conscious experience is all phenomenality. It's all subjective. It's all qualia. How do we square that with physical explanations? That's the hard problem. Yeah, the knowledge argument is interesting. Well, I mean, again, that's a thought experiment. So it really depends on what you think, right? Yeah. A lot of people, I mean, I kind of like, your Dennett's, your Keith Frankish is another one, your illusionists, right? Qualia aren't real, which doesn't mean they don't exist. It's just that they're mind dependent. Yeah, but we better not. Yeah, Quining qualia, I think, is the paper you're talking about. Or chapter. It might be a chapter. But Jack, yeah, I think that's Quining qualia. Quine was Dennett's supervisor, his undergraduate supervisor at Harvard, by the way. So Dennett is, kind of Quinean, or was. Dennett passed away quite recently, actually. A big loss for philosophy, because that guy was a philosophy machine. But yeah, we'll return to qualia more in the final chapter. But I mean, qualia is tricky. Like, we don't know, like, why is red red and not some other color? Why does coffee smell the way it does and not like something else? You can say, like, oh, well, redness, it has to do with light of a certain wavelength, 700 nanometers. The smell of coffee has to do with its molecular profile. But that's just kicking the can down the road. Why does light with a wavelength of 700 nanometers produce that quale? Why does the molecular profile of coffee result in the smell that it has? We don't know. This is the hard problem. So it's tricky. And if you find yourself a bit perplexed about these questions, don't worry, because everybody is. Let's talk about the cross-wired brain. This is a fun one. Suppose, as Kim has us suppose, that each of us has a pain box and an itch box. We can think of the pain box as consisting of a bundle of neural fibers somewhere in the brain that gets activated when we experience pain. And similarly for the itch box, So it might help if I could draw. I wish I had a whiteboard, but I don't. I do have, however, a piece of scrap paper. Let's see if I could draw this. Of course, it would help if I had a good pen. Okay, so let's say I have my pain box and I have my itch box. Okay. So we have our pain box and our itch box. We need some inputs and outputs. So let's say tissue damage. And our input for our pain box or for our itch box will be skin irritation. And our output for tissue damage will be winces and groans. And for itch behavior, we'll just put scratching. So there in my little chicken scratch diagram, we have tissue damage, sensation of pain, winces and groans, skin irritation, sensation of itching, scratching behavior. So that's our pain, pretty straightforward. Now suppose a mad neurosurgeon rewires your brain by crisscrossing both the input and output channels of your pain and itch centers. That is, the signals from your pain receptors now go to your former itch box, and the signals from this box now trigger your motor system to emit winces and groans. Similarly, the signals from your itch receptors are now routed to your former pain box, which sends its signals to the motor system, causing scratching behavior. No, good question, Taylor, but the output doesn't always have to be physical. It could be another mental state, but we're just going with this for simplicity's sake. So let's erase these and rewire our pain box such that skin irritation goes to my pain box and produces scratching, and tissue damage goes to my itch box and produces winces and groans. So again, this is messy. I'm sorry this is so messy. It would help if I had a whiteboard, but you can see here, I've crisscrossed the input. So my tissue damage is now wired to my itch box, and the output of the itch box goes to the pain behavior, and likewise, vice versa for the itch box. So now I have tissue damage going to my itch box. Presumably I feel an itch, but it causes pain behavior, winces and groans, and going, ouch. On a functionalist view, there's no real difference in terms of inputs and outputs, right? But am I feeling itch when I stub my toe? And am I feeling pain when I have skin irritation like a mosquito bite? If I subjectively feel an itch, do I scream, ow? If I'm in pain, do I scratch? This is essentially another version of the inverted qualia objection. It's just more specific to pains and itches rather than like the visual spectrum. Michael says, if one society defines the result of tissue damage as pain and another defines it as itch, they're both talking about C fiber activation. The definitions are there for communication, and they will not be communicating well unless they refer to C fiber activation. Well, okay, but in this case, here's what's happening. The pain box is where my C fibers are. Now, when I've rewired my brain, if I get skin irritation, it causes my C fibers to fire, and then output scratching. Okay, but the question is, phenomenally speaking, what am I experiencing? Do I experience pain when I have an itch? It would seem so on my rewired brain, but my output would still be scratching. So the functional input-output relationships are the same with the cross-wired brain. The qualia are not. And that's the issue that this little thought experiment is raising. I don't know why they would. I also don't know why a society would define it like this, right? these would just be two different words for pain in that case. But that's a little bit different than what's going on in this thought experiment. Does it though? That's the thing. Does the tickle box become the pain box? In terms of inputs and outputs, sure. Isn't the behavior connected to the qualia? Not if it's no. So look, if I rewire, so if I'm straightforwardly in pain and I haven't had my brain rewired, then I have tissue damage, C fibers firing, and a sensation of pain, and then pain behavior. But the way this is rewired is that now I have skin irritation going in here to where my C fibers are. They fire, and I have an output of scratching, but phenomenally, I'm in pain. When otherwise I would just experience an itch. So here the behavior is not connected to the qualia. And this is perfectly consistent with what functionalism says. And that means we've got a problem. Not if your brain is wired the way that we want it to be wired for this thought experiment. Because if you stub your toe and feel a tickle and then scratch, then we've rewired one of the channels, but not both. That would be like skin tissue damage wired to your itch box, wired to your itch output. But what we want is pain inputs wired to the itch box, wired to pain outputs. Why would it not be interpreted as pain, Jill?
If the itch is interpreted as pain, that's a personal experience. So would it not be? That's why I was saying, would it not be the same as the beetle in the box? It's what that one mental experience is.
Right.
Not
But
everyone.
remember, the outputs have also been crisscrossed. So I get tissue damage, I feel an itch, but because this mad neurosurgeon has rewired my brain, I don't scratch. I go ouch because my brain's been wired up incorrectly. The result is that we get the same behavior that's consistent with what a functionalist wants, but the internal states are all wrong.
So the C fiber would only be a pain output.
Right, but my brain's been rewired.
Okay.
That's the point. My brain's been rewired. Like an example like this would probably never happen, right? It's completely imaginary. But let's imagine that it could happen. So I have my C fibers firing, not when I have tissue damage, but when I have skin irritation. But then in addition to that, the outputs are crisscrossed too. So I don't go ouch, rather I scratch.
It's a stretch.
Well, it's meant to be a stretch. It's a conceptual exercise. It's not something that could realistically happen. It's something, it's a thought experiment that shows a conceptual problem with functionalism. Would the experience of qualia, no. So what's happening? Maybe I'm trying to simplify this. Is there another piece of paper? Here's another piece of paper. Let's try with just pain. Okay. So I have my pain box with my C fibers in it. Now, let's say I've only we're not going to worry about the itch box, but let's just worry about the itch inputs and outputs, which I, as a mad scientist, have connected up to my pain box. So I have skin irritation, which would normally go to my itch box, but instead it goes to my pain box and my C fibers firing. I have the qualia of being in pain. It hurts, but I don't go ouch. and withdraw from the painful stimulus. Instead, I scratch. I have the same, I have input-output relations that would be perfectly fine for scratching behavior, but my internal state is wrong. My internal state is not one of pain, not one of itch, it's one of pain. Now, functionalism says, okay, it's fine. We've got skin irritation, goes in. We've got scratching behavior that comes out. What's the problem? The problem is the qualia is all wrong. You see what I mean? I know it seems wildly implausible because it is, but it's an imaginative exercise. That's the important thing to remember. It's like, probably there aren't inverted spectrum cases out there, but we could imagine what if there were. Exactly, it's conceivable. Like you could conceive of a mad scientist, probably, within the next little while, we're not going to get this good at neuroscience, but it is conceivable that some mad neuroscientists in some imaginary scenario could do this. You're right, Jill. It's not practically possible, but it's logically possible. And that's what we care about. So it's kind of like going faster than the speed of light. We can't do it, but we could conceive of it, right? Yeah, or it might be possible in another world. Like there's a logically possible world where everyone's reds are what violet look to us in this world. And then we can think through the consequences of that. This is something called modal logic that deals with the logic of possibility. So it's not practically possible to rewire a brain like this, but conceptually, there is actually no problem with doing this. We just have to remember that we're imagining. We're imagining things. Again, and we do this to clarify our concepts and our beliefs. Yeah, so Hyla, that's right. The qualia is being in pain, but you scratch. And that's the appropriate behavior of if you had the internal state of itching, but your brain's been all cross-wired, right? So the functionalist would say, hey, what's the problem? Well, the problem is you're not dealing with the subjective aspect of the internal states. You're not dealing with qualia or subjective consciousness. And that's a big problem with functionalism. I love functionalism, but it does not deal with consciousness. And that's a big problem because consciousness is the number one mystery that we all want explained, right? Why is red red and not some other color? Why does coffee smell like coffee and not something else? Why is there something that it's like to be conscious at all? Why aren't we just zombies or automatons? That's the big question, right? I cannot fathom being in pain and thinking the scratching will make it go away. Yeah. Yeah. Yeah, imagine that. But you wouldn't scratch. You got shot, you'd feel itch, but then you'd still go, oh, I've been shot. Right? So yeah, remember, so that's the key to this thought experiment. It's not just the inputs that are rerouted, it's also the outputs. So let's talk about roles and realizers. I'm skipping over a little bit of the chapter because we did get into a good bit of discussion there. Most functionalists believe the following four things, or they want to believe the following four things. They believe, firstly, that psychological cognitive properties are multiply realizable. We're pretty straightforward on what that means, right? It means that you can implement some information processing thing, this or that, in different physical stuff. You can implement 2 + 2 = 4 on a pocket calculator, on a virtual calculator, on an abacus, on a Turing machine, etc., right? So we're all clear on multiple realizability, right? Because this is like one of the most important takeaways. The thought experiments are fun and confusing, but This is the real meat and potatoes, as it were. Okay, so it looks like everyone's clear on multiple realizability. Now, as a consequence of one, these psychological cognitive properties are reducible to physical properties. We're not doing what the physicalists did, like the type physicalists. We're not saying pain is C fibers firing, but in the case of the human being, pain is realized by C fibers firing. In the case of the octopus, it might be X fibers firing. In the case of Martians, it might be Zorp matrices flarbing, or whatever Martians' physiology does. But in any case, they're all reducible to physical properties. 3, this does not affect their status as legitimate scientific kinds. So even though mental states can be instantiated in multiple different ways, they are still real natural kinds. They're real things. Mental states and events are real. They're natural kinds. It follows from this that the cognitive and behavioral sciences form an autonomous science that is irreducible to more basic lower level sciences like physics and biology. This is what we want to believe. And this is what other scientists give us a hard time about. You know, you'll get your physicists going all like, it's all reducible to atoms and stuff, man. But we want to be mental realists. If we're functionalists, we're mental realists. So mental states are not reducible to more basic lower level phenomena. And so the cognitive sciences are not reducible to more basic lower level sciences like physics or biology. That's what we want to believe. The operative word is want. Whether 4 is true is a matter of some debate, and probably will be for many, many years to come. Is it true that the cognitive sciences are really irreducible, I should say, to lower level sciences? Aldwin's in support of the irreducibility of the cognitive sciences. No, it doesn't mean that they're not physical per se. It means that they are. We're talking about like something like a property dualism here, I think. I can't reduce pain to C fibers firing because there are other ways to instantiate pain. But I can say that pain is real. It just could be realized in multiple different ways with different kind of stuff. So it's dependent on the physical because it needs a physical realization. It's also dependent on the physical because all of the inputs and outputs and internal states are all causally related to one another. And that can only be true if they are physically realized. So they're physical in that sense. But what we're doing is probably opting for some kind of property dualism or maybe supervenience or something. So is it really true that these are all irreducible? Well, maybe it looks that way because we're focusing on low-level realizers, right? By focusing on these low-level realizers, we lose sight of their unity as properties. We might be missing the proverbial forest for the trees, right? So instead of focusing on realizers, and by realizers, I mean things like C fibers or neural networks or computer chips, the physical stuff, the lower level stuff. Maybe we should focus on the roles of these realizers. This is where we can carve out two different kinds of functionalism: realizer functionalism and role functionalism. What does Kim say about realizer functionalism? He says on page 187, oh no, I've screwed up my parenthetical reference. Oh no. On realizer functionalism, my experiencing pain at time t is identical with my C fibers being activated at t, where C fiber activation is the pain realizer in me. The octopus is experiencing pain at t is identical with its X fibers being activated at t, where X fiber activation is the octopus's pain realizer, and so on. The property instantiated when I experience pain at t is not identical with the property instantiated by the octopus when it experiences pain at t. And that is because our realizers are different. C fibers in the case of my pain and X fibers in the case of the octopus. So we're focusing on the realizers, and because we have different realizers, my pain and the octopus pain, they cannot be identical to one another. They are not the same kind of thing. Not really. Maybe, subjectively speaking as well, pain for me is still negative. Like if we're going to talk about how it still feels bad to me and the octopus, but it feels different, but still bad to the octopus than it does to me. Or you can look at role functionalism, the role of the realizers, which also on 187 says, my experiencing pain at time t is identical with my being at t in a state that plays causal role R. That is the role of detecting bodily damage and triggering appropriate behavioral responses. The octopus is experiencing pain at t is identical with its being at t in a state that plays the same causal role R, and so on. My pain at t and the octopus's pain at t share the same functional property, namely being in a state with causal role R. So on here, our human pain and octopus pain is identical by virtue of the fact that they share the same functional property, but they're different on realizer functionalism by virtue of the fact that they are instantiated by different physical realizers. It's a subtle difference, but do we see the difference? Aldwin says yes. Good, good, good. Who does not see the difference? Anyone having a little trouble? Because it's still pretty abstract here, this stuff that we're talking about. How are we doing for time? We're doing pretty good for time, actually. Well, we can unpack some of the differences here on the next slide. So Kim writes on the next page, where the realizer functionalist sees differences and disunity among instances of pain, the role functionalist sees similarity and unity represented by the pain's functional role. So a role functionalist would say that the role properties are what are real, the real subject matter of the cognitive sciences. So if you're a cognitive scientist, a role functionalist would say that what your job is to discover the laws or law-like regularities that hold for these properties. And you can do this without really focusing on the physical or the implementational details. You can do this without worrying precisely how things are realized. But the role properties have to be robustly causal. They have to be nomological. So they have to be causal and they have to be law-like. As role functionalists Ross and Spirit, quoted in Kim on page 188, say, the foundational assumptions of cognitive science, along with those of other special sciences, deeply depend on role functionalism, not realizer functionalism, role functionalism, which is the type of functionalism that sees the functional roles as identical across different realizers. Such functionalism is crucially supposed to deliver a kind of causal understanding. Indeed, the very point of functionalism on role or realizer versions is to capture what is salient about what systems actually do and how they interact without having to get bogged down in the micro-scale physical details. What do you think? Well, I'm a cognitive scientist, so I guess I should probably pick a side. And I guess as functionalism goes, probably a role functionalist when it comes to understanding behavior. But I have to admit, realizer functionalism has a certain appeal in terms of the potential that it may have to explain differences in qualia when it comes to humans and octopi and aliens and so forth. What do you think? This is the second last slide, so we can just shoot the breeze about functionalism for a few minutes before we wrap up. But I mean, and hey, maybe you've only had like 5 minutes to think about this. Like, what am I, a role functionalist or a realizer functionalist? I don't know. No, role functionalism is functionalism, but it focuses on the roles that mental states play. Not so much on how they're not so much on how those mental states are realized. Aldwin says maybe the size and the number of C fibers and the differences that in each person cause entail different qualia. I mean, maybe. Some people do seem to have greater or lesser tolerances to pain. In fact, there are some disorders, like I believe Kim mentions this one in this chapter, like congenital analgesia, where individuals don't experience pain. And often these people don't live very long because, they get hurt badly and they don't realize how badly they're hurt. And then they end up dying from their injuries. I think there was an episode of House where there was a patient with congenital amnesia, and she was in a car accident. That the cold opening was like, there's a car accident and her mom is lost consciousness because she's hit her head, and she's calling the ambulance on the cell phone, and they're like, ma'am, are you okay? And she looks down at the bone jutting through her leg and she's like, I'm fine, but you got to come and help my mom. She doesn't experience pain. That's absolutely wild. And then there are just individual differences. Some people also train themselves to endure more pain, like, showing my age a bit here, but you guys know about David Blaine? Yeah. He's a magician, but he also does stuff like freezing himself in a block of ice or living in a goldfish bowl, or he did one where he stood on a pillar. He did one where he was buried alive for a few days. Yeah, the breath holding one was weird because he like lived in this giant goldfish bowl for like a week, and then at the end he tried to break the world record for holding his breath, which he came close to doing. I don't think he did it, but he did come pretty close, which was impressive. Mr. Beast back in the day. Did Mr. Beast do that? I don't know about Mr. Beast. I try not to watch Mr. Beast. Just because he did get buried. Oh, well, I guess, yeah, that David Blaine did that first, and Mr. Beast maybe did a similar version, but yeah, so somebody like David Blaine is going to be like trying to train himself to endure the pain and maybe not notice it as much. Or like that guy, what's his name? Wim Hof, who likes to go swimming in freezing cold water all the time, And some people like pain. I've said it before. There are people that like to go and get a runner's high. There are people that like to, they go to the gym, they get the pump on, and they're sore the next day, but they are it's a happy sore. Yeah, Aldwin, yeah, you called it. There are those BDSM folks as well. They like the pain. Some of them like having the pain inflicted on them. Others like to inflict the pain on the others, right? So, you know, they exist. Aldwin also opts for role functionalism. Yeah, okay, fair enough. Like I said, role functionalism is great. Realizer functionalism is kind of appealing. I mean, maybe we need to look at realizers to understand consciousness, but then again, the hard problem is still there. So the Turing machine. So Hyla, this was mostly the topic of the previous lecture. But in essence, it's an imaginary machine that Alan Turing used to formalize the notion of computation. And it has tape with cells, and we can type information onto the cells. It has a machine head that moves the tape and writes and deletes cells. And it has a machine table, which defines all of the states that the machine can be in. So it's like a computer program. And yeah, we can understand our minds as probabilistic Turing machines. And also the computer that you're on right now, if the Church-Turing thesis is correct, is a universal Turing machine. It's a Turing machine that can run any specialized Turing machine. Beyond that, you know, if you've got questions about Turing machines, it's a good idea to re-watch that lecture because it's all there. Any other questions about anything before we go? I mean, what is it precisely about Turing machines that is there a particular thing about them that's confusing? In the meantime, I'll answer Michael's question. He says, should we start the final essay before you provide feedback? How likely is it that you would reject the pursuit of the thesis of the essay proposal as being valid? Well, I don't recommend getting started on writing, but definitely get started on research. It's not very likely that I'm going to outright reject your proposal. If things are kind of a little worrisome, then what I'm going to do is kind of point you in a different direction, but I won't be like, no, start over again. I won't do that. But I will try and steer you in a better direction, potentially. Quiz 3, we're covering the chapter on identity theory. So, psychoneural identity theory, and machine functionalism. So that's chapters 4 and 5, if I'm not mistaken. And anyway, it's the chapter on identity theory and then the following chapter on Turing machine functionalism. Hopefully that answers your question, Jacob. Jack, is it okay to switch sides on a thesis that, like, to switch your topic or to change the direction of your argument? Both are acceptable. You can change your topic completely, but you have to let me know so that I can make sure you're still kind of on the right track. If you are like, okay, I'm going to argue against this, but then in the course of your research, you actually decide to argue for it, that's fine. And you probably don't need to let me know. You can just make a little footnote in your paper, like, initially I thought this, but now I think this, you know, and then get on with your argument. So that's fine. Any other questions about anything? Okay. Well, there's only 17 of you left, so people want to go and enjoy their day. So that's all. If you think of any other questions about anything, of course, let me know. And I will see you all on Wednesday when we talk about mental causation. So definitely read chapter 7 for that lecture. All right. Thanks, everyone. And I will see you on Wednesday.